my name is Zheng Chen, and I am an assistant professor at Linköping University. Today I will talk about my research when complex networks meet decentralized machine learning. So complex networks refer to the kind of study on how things are connected in networks. And the word complex comes from the fact that we are mostly interested in large networks with complex topologies instead of small-scale networks with very simple topology. And we can model the connectivity between the nodes by using graph models. And the graph model consists of two parts, a set of nodes, which represent the elements in the network, and a set of edges, which represent the connections between the nodes. So here is one example on research collaboration network. Each of the nodes here represent one researcher in our area of research. And if there is a connection between two nodes, it means that these two researchers have co-authored a certain number of research papers together. And the thickness of the connection determines how many papers that they have co-authored together. And then by applying some spectral clustering algorithm, we can also observe the community structure of the network that is illustrated by different colors in this figure. So we have seen the definition of complex networks, and now we will talk briefly about machine learning. By definition, machine learning refers to the area of study of how we can let computer programs to learn and improve its actions and performance by using training data. And in this particular example, I show a machine learning algorithm that uses a deep neural network to perform a classification task that recognizes some handwritten digits. So this deep neural network consists of many interconnected layers, and each layer has a set of neurons, and each neuron has a weight. So the set of weight of these neurons, which we can call model parameters, would determine the output of the algorithm given a certain input. So if we write some handwritten digit there at the input, then at the output, we should be able to get the right labels. And in order to make this algorithm work, we need to feed some training data into the deep neural network. And this training data consists of some handwritten digits and their correct labels. And then by applying some iterative optimization method at the deep neural network, eventually we will get a set of trained parameters that will be able to produce the right label given the images on the handwritten digit. So in a classical setting, when we have a set of devices that are participating together in a common machine learning task, all the devices will send or upload the training data to a centralized server. And the server has the machine learning algorithm, and it will collect all the data that it receives from the set of devices, and then it will train the machine learning algorithm and will produce the best model parameters. But then there are two problems in this centralized training. The first is that it generates privacy concerns about how the data is used and how our data is shared to some other people or other organizations. And ideally, we do not want to share our private data with other people. And the second problem is that the repeated uploading of training data also generates communication and energy cost. And this cost can be significant if the training data contains high-definition images and videos. So we can consider an alternative setting, which is called decentralized machine learning. So with this setting, we have a set of devices that are interconnected. They all share the same machine learning model, and then they all own their own training data, and they do not share this training data with each other. Instead, each of the device performs local training of the machine learning model based on its own data, and then it shares the information or the update on the model parameters with its neighbors. But since we do not have a centralized unit coordinating the actions and decisions of the devices, how can we make sure that all of the devices will eventually reach the common trained model? Then a key concept or technique that can be used to achieve this goal is called distributed consensus. Distributed consensus refers to the problem of reaching agreement among a set of nodes in a distributed system that only relies on local information exchange. And this agreement can be some decisions, preference, or some continuous valued measurement data. So in this figure, I have shown two examples. On the left-hand side, we have 3 nodes, and each of the nodes has preference on what to drink, either tea or coffee. So 2 nodes prefer coffee, and 1 node prefers tea. And then by sharing their preferences with their neighbors, and then we apply a majority vote at each of the nodes, and eventually all the nodes will agree on coffee. And on the right-hand side of the example, we have 3 nodes that observe some measurement data, and then they exchange their data with their neighbors, and then each of them will calculate an average of the received data from the neighbors and of its own data, and eventually everyone will agree on 1.4 as the observed data. In these 2 examples, the process of reaching agreement is rather straightforward and simple because we have a fully collected network, meaning that everyone is connected with everyone else. But in a complex network, with complex topology, this problem can be much more difficult and also much more interesting. So now we go back to decentralized machine learning over networked agents. At each of the devices will follow an iterative procedure to reach a common agreement on the trained model parameters. In each of the iterations, every device will aggregate 2 parts of information. The first part is called the consensus part, which means the information or update on the model parameters that it receives from its connected neighbors. And the second part is called innovation part, which contains information or update on the model parameters that are obtained from its own training data. And then by aggregating these 2 parts together, each of the devices would update its local model parameters and again share it with its neighbors. And this procedure repeats until all the devices converge to the same trained model parameters. However, in real-world applications of decentralized machine learning systems, such as autonomous vehicles and swarm robotics, the information exchange between the nodes takes place over wireless links. And wireless links are imperfect and reliable. Even if we send some perfectly shaped sinusoid signal at the transmitter side, at the receiver side, we'll always get some distorted signals due to noise and some other impairment in the system. The amount of data that can be reliably transmitted over a link is also limited. That creates delay in the message passing process. And the connectivity between the nodes will also change over time. And all these features will create additional difficulty in the performance of decentralized machine learning over wireless networks. In order to build the theoretical foundation of distributed intelligence systems, we must look into the intersection between several disciplines, including machine learning, complex networks, and communication theory. And my research work is focused on the broad scope of distributed intelligence systems with special focuses on different aspects that are associated to this concept, such as resource allocation, signal processing, fault tolerance, reliability, and so on. And this is a very new and challenging research area that will have a significant impact in 6G mobile networks and the Internet of Things. Thank you for watching.
Well, thank you, Zheng, for that presentation. Very interesting and a bit, well, complicated for me. So I'm glad I have the opportunity to ask some questions. And here you are.
I'm also glad to be here answering your questions.
Yeah, well, great. I think it was quite, well, fascinating to listen to you. And I know that soon I will get the picture even better. So, but first, we're in Linköping doing this interview. How come you came here? Because you're from China.
Yeah.
Is this as a student or what?
So I originally come from China, and then I did my master and PhD studies in France. And then after I completed my PhD degree, I came here as a postdoc researcher in 2017.
Okay.
And then this year I started my new position as a assistant professor here.
Wow, great. So we can do this interview in French as well?
Comme vous voulez.
Non. Non. Pas du tout. Was that okay?
Yeah.
No. I've forgotten all my French, so it's easier to stick with English. Well, and now we're in Linköping, and you're very much into these. Well, we heard about these complex networks.
Yes.
But also the decentralized learning systems.
Yeah.
So just give me some kind of example within the society. Where do we find these? Can you give me any examples of how we are using this or how we will use it in the future?
Yeah, so one promising application that I can see is autonomous vehicles.
Okay.
Because if we want to upload all the video data to a centralized server to process all the data and then to send back the decisions for each of the vehicles, it will be very costly, and then it will be also generate a lot of unnecessary data traffic. So that can be a good alternative option if we can process those video data locally in each of the vehicles, and then they just exchange the information that they have with the nearby vehicles, and then they can figure out the best strategy that is for everyone to avoid to avoid congestion and then avoid the car crash or other accidents.
So when you show a device as a cell phone, it could be a car.
It could be a car, it can be a laptop, it can be a sensor, it can be anything.
So all the cell phones just are the symbols of
it's just a symbol of something that can transmit and receive information.
Okay. So this is because I think the picture, when I realize that this must be the case when it comes to vehicles and all the traffic system and all the complex situations.
Yes.
So we have some kind of interactions between the devices, the cars, and do we have a cloud involved with this also, or will it just be in between the cars, the devices?
That may depend because there are two types of decentralized machine learning. You can still have centralized units that collect the model updates from the decentralized devices, or you can have a fully decentralized system where the information exchange only happens between the devices or the agent.
So and when you have a complex network, a centralized, is that the cloud? Or
in this
could that be the I'm just using the words I know. I know. So when you have a complex network, could that be that could be the cloud?
A complex network refers to many nodes, interconnected nodes.
Okay.
A cloud is more like one centralized unit where we could process all the information that we have. So the cloud is not
when
a network.
I can read about data centers. Oh, we're building a big data center.
Yeah.
Where come those into play? Are they in your system as well?
In this particular setting that I have talked about, no, we don't have these kind of big data centers that collect and process everything.
No.
Yeah. So the key idea is to keep the data locally and the computation also takes place at where the data was generated.
Okay, so that's closer to what they say. Well, I learned edge computing with
Yeah.
base stations.
Exactly. Mobile edge computing is very related
Okay,
concept.
so and we have the base stations all around us.
Yeah.
So instead of sending the information away, it will stay within the local area.
Yes, that's
So
the key point.
this is definitely a part of your research.
Yeah.
Okay, great. I'm getting into it now.
Yes.
Okay, great. So just when you have these complex, well, you're showing you have red and green, and do they symbolize anything, or you can choose whatever? I'm just curious how you are well giving it colors. The red color, that will always mean that, or that doesn't make any difference?
Not really. The colors are mostly to make a difference between the information flow from different users.
Yeah.
So if I have a green node, then I mark the information.
So that's just making it easier to understand.
Yeah.
It doesn't mean anything actually.
Doesn't mean anything.
Okay, great. So I'm just thinking. You showed cell phones.
Yeah.
Could it be my cell phone?
Anyone's cell phone.
Anyone's cell phone?
Yes.
Will this happen without me? Me knowing about, without I'm not aware of it, or do I have to give I will permit it?
Yeah, that comes to another question, whether you give permissions to your own data to be used for machine learning tasks. But that is not what we care about.
No.
Yeah.
But will it be a decision, of mine?
Yeah, I believe there ought to be a decision to be made that gives your consent on how those high-tech companies could use your data.
But will they use the cell phone in itself? We can use your cell phone for just a short period of time. We can gather some information there, and then in a couple of minutes we will take it. Can I use it? Will it be part of a big system where without I'm aware about it?
It is possible. It is something that we would like to avoid.
Yeah. Because it's when you always get all of these tricky questions about integrity and my data and who's using this, who will the big decisions about these, are they on the government to decide, or the big companies? Who will use these these techniques?
I believe that should be a decision that is made between the government and also the companies, and then to figure out a model that protects the best users' privacy, and at the same time could help the companies to improve their algorithm and their services that they provide.
Yeah, and you talked about 6G.
Yeah.
Because some of us have just learned 4G. And now we have 5G, and then, why are you talking about 6G? Can you just give us, how will this be important for 6G, and what could the 6G technology bring that we don't have today?
Yes. In my opinion, of course, many people can have different views on 6G and what will be the most important component of 6G mobile networks. But in my opinion, I believe the main change from 6G as compared to the previous generations of mobile standards is that we will have to face the challenges of a lot of interconnected intelligent systems. And those data traffic that we need to handle will be different from the old types of data traffic, such as text messages and then videos and the images. So we need to come up with an efficient design to support the information flow and the information transmission and reception within large, distributed, interconnected intelligent systems.
Yeah.
And then that is where what the core of my current research, how does wireless communications and networking and cross-layer control integrate to best support large intelligent systems.
And the things you are looking at, it won't be possible if we don't get the 6G system. Is that right? Can you do this in a
Yes.
5G environment?
Yeah, you can do that because there is
How will it be better in a 6G then?
6G and the 5G are mobile standards. It
Yeah.
specifies a range of techniques that will be used in the network, but it doesn't mean that they are mutually exclusive. There are some scenarios that are both common that would probably be still used, that are used in 6G that will still be used in, there are probably some techniques that are used in 5G and that will be using 6G again.
Yeah.
And also it doesn't need to be any specific type of standards because as long as we have a large interconnected intelligence system, then we can apply my research result in that scenario.
I'm just curious, are we still using 3G in some ways?
I believe somewhere in the world, yes.
Okay, in Sweden?
I actually don't know.
Okay.
Yeah.
I realized that we use 4G and 5G and 6G at the same time.
Yeah.
Okay, so just when we are getting into the preparations for the society, well, in Sweden or all over the world, and we can do it in a proper way, or we can, well, by being foolish, not get it right. What will be the most important part that we've learned from recent years that if we don't think like that, then we can't use the full potential. So what is needed for, what kind of decisions, what kind of things should we develop now or the coming years to enable a full potential of 6G?
That all the sub-branches of electrical engineering field should work together on understanding each other better and then to integrate computation, communication, control, machine learning together.
Yeah.
And then to make the best use of it.
So instead of going one by one and keeping walls, collaborate, build this together.
Yes, to merge the boundaries.
Okay, great. And do you think that will happen?
I believe so.
Yeah. And also, can you see examples in the world? Because we have China, we have the United States, we have Europe, Africa, different decisions, different political systems. Will we be able to come together and build a good system for us all, do you think?
Yeah, I believe so.
And you can see the signs that this is happening.
Yeah, I can see that now there are more and more interdisciplinary research going on all around the world, and I think it shows a positive sign.
Okay, great. Just give us your vision. Well, let's say 20 years from now. How do we and all these the best? It will your best wishes. It will happen. Just imagine that. So what kind of world, how do we live? What kind of opportunities can you see when we have this system established? What are your thoughts about the future?
Technology-wise.
Yeah, technology-wise. Now, that's the other way. We can leave the other.
Yes.
But from this perspective, with our decentralized systems, how will, for a normal person, how will this affect our lives?
Yeah, that we will have, for example, like if we can really make Internet of Things happening, then we will have a lot of integrated, smaller, like intelligent systems that are interconnected in a larger scale. And then at home you will have like smart home systems, and then at factories you will have automation and intelligent factories, and then for transportation systems also. And then we will together have, with all these technologies together, we will have a more efficient, more intelligent, and also more reliable network system, or a system that makes our daily life much easier.
Great. That sounds nice.
Yeah, this is what I'm looking forward to seeing in the future.
Well, I think that will happen also. I realized I have one question I haven't asked you. I hear about the importance of having good quality data.
Yes.
And we're collecting data from all. How do you filter it out in this system? How do you get the right amount of data and the proper ones?
This is not the focus of my research, honestly. So my focus is that given that we have this amount of data, how we should best process it and then allocate the appropriately the communication resources to the participating devices and then to achieve the best learning outcome given the communication resources. So I don't focus on the generation of the data part.
Okay, but there's some other clever people doing that, I believe.
That would be another bunch of other researchers working on that.
Yeah, great. And I think they are somewhere.
Yeah.
Well, thank you so much for, it's been very interesting, and I know much more now, and it makes sense. So thank you for being here, and good luck with your research.
Thank you. It was a great pleasure to be here today.
And thank you also watching from home or wherever you are, and we will be back with more presentations some other time. So thanks from Linköping and today.